Okay. Just I think. Okay. So now, yesterday I told you that sandwich theorem. Sandwich theorem says if you have three sequence an, bn, cn and a real number c such that an is less than equal to cn less than equal to bn for all n, then an converges to c as well as bn converges to c, then you can say cn must converge to c. I have done one example on sandwich theorem in previous lecture. Now, actually some students were interested in the proof of this. So proof is simple. So I am doing the proof of this theorem. How it is? Let epsilon is greater than 0 be given. Since A and this sequence converges to C. So for you can write epsilon is greater than 0, there exists a natural number n1 such that I am applying only the definition mod an minus c is less than epsilon for all n is greater than n1. Or what can you write? Minus epsilon, if you open this, a n minus c is less than epsilon for all n is greater than n1. And what you can write, this is c minus epsilon is less than an is less than c plus epsilon for all n is greater than n1. Or you can write in terms of interval, this is same, c minus epsilon, c plus epsilon for all n is greater than n1. Suppose this is one equation. Again, since bn, this sequence bn converges to c, so there exists n2 element of n such that how mod bn minus c is less than epsilon for all n is greater than n2. If you do the same exercise, it will be c minus epsilon is less than bn for all n is greater than n2. Do more work. So this will be same thing, bn element of this interval c minus epsilon, c plus epsilon for all n is greater than n2. This is true. Now here equation 1 is true for all n is greater than capital N1 and equation 2 is true for all n greater than n2. Both equation will be true for all n which is equal to the maximum of n1 and 2. So I have done this exercise. Choose m is equal to maximum of n1 and n2. If you choose this, so both equation 1 and 2 will be hold for n is greater than equal to m. Now, we have, it is given that an is less than cn is less than Bn for all n natural number. So here can I say from 1 and 2 and 3, suppose this is 3, no need to write 3. Can I say this Cn will be the element of this C minus epsilon, C plus epsilon for all n is greater than m. Because 1 is true for greater than n1, 2 is true for greater than n2, and third is true for all n. So simultaneously all the three equation will be true for n is greater than equal to m. So value of Cn is greater than equal to an and less than equal to bn. You can write in this form. Cn minus epsilon, sorry, C is less than epsilon for all n is greater than m. That means Cn converges to C. Kartikeya and Shrestha, don't ask me such type of question, sir, it will come or not. Whatever I am teaching, anything can come related to that. Okay.
Sir,
So
can you
this is,
explain after third equation?
yes.
Sir, please explain after third equation 3.
Third is saying it is given, actually this is given question. You can see value of Cn, this is less than between an and bn for all n is equal to 1 2 3. So suppose if you take, suppose n1 is equal to 4, n1 n2 is equal to 6. So this means equation 1, this equation 1 is true for greater than equal to 4. Equation 2 is for 6, or equation 3 is true for all 1 2 3. So can I say all three equations are true for n is greater than equal to 6?
Yes, sir.
So that's why I did the same thing.
Okay, sir.
Okay. I did the same thing because m is the maximum of n1 and 2. So this is, it will be true for all n is greater than equal to m. If you have to, you can say Cn converges to C. So this is
Okay,
the
sir.
proof of Sandwich theorem, because some students were asking for the proof, so I did this. And you can realize how it is coming. Now let us do another example. It says let you have a real number R such that 0 is less than x is less than 1. Question is sequence xn converges to 0? This is the question. Check the convergence. So solution, I will use the binomial theorem. Result of binomial theorem. What is that? That is known as also known as the Bernoulli's inequality. It is derived from the binomial theorem. It says if alpha is greater than 0, then 1 plus alpha n is greater than 1 plus alpha n. You can write alpha 1 plus x raised to power n, 1 plus nx plus nc2 nc3. It is derived from there. So this is, you can write 1 upon 1 plus alpha n is less than equal to 1 plus n alpha, or this is equal to 1 upon n alpha. Yeah, you can write in this way because you are You are removing 1 from the denominator, so this is less than equal to, yeah, you can say not less than, this will be this. Okay, now we write x. Here x is lie between 0 to 1. So I want to express x in such a way that it lie between 0 to 1. So 1 plus alpha I am writing for alpha is greater than 0. So this is same as you write in this, as he is asking 0 is x lie between 0 to 1. If you write in this way, this is same. So now x n, this is a sequence, this will be equal to 1 upon 1 plus alpha n. Apply Bernoulli's, so this will be less than 1 plus alpha n, finally 1 upon n alpha, because these are positive, this is this. So finally you have 0 xn is less than 1 upon n alpha. Suppose this equation is 3. Here, we know that 1 upon n converges to 0. And alpha is a real number. So by the third property of third limit theorem, 1 upon n alpha also converges to 0. We know that sequence 1 upon n converges to 0. So 1 upon n alpha also converges to 0 for alpha is the element of R. Alpha, sorry, this is greater than 0 also. Okay, so it means 1 upon n alpha, this is converges to 0, and this sequence 0, this also converges to 0, and this is a constant sequence you can consider. So here this converges to 0, this converges to 0. Here is strictly 0 is less than strictly, if you see the sandwich theorem. Sandwich theorem, this is less than equal to or condition. It will be equal or less than. Equal or less than. So don't confuse. So here, by sandwich theorem, xn will converge to 0. So this is the solution of the example. Bhargav, Jitendra, yes. What is the meaning of Bhargav, Jitendra? Okay. Any doubt? If you have, write on the chat box. Now, I do a nice result. Next nice result. This, with the help of this result, you can also find the limit of some sequence. Not all, but some sequence. This is known as the ratio test for sequence. Be careful.
Excuse me, sir.
Yeah.
Sir, how we will know that we have to apply the Bernoulli's inequality in this question?
Actually, if you solve a mathematical problem, so you can use any previous result. And now question arises, how? It comes from the experience. It comes from the practice. So you need, actually, you need to see, there may be other solution also. I'm not saying that you use Bernoulli, but this is one solution. You need to see, you need to write, if you want to apply the sandwich theorem, you need to write x की power n such that it will be greater than one sequence and less than other sequence, but convergence of those sequence we know. That is our main motive. You can use other also. Okay? क्लियर थिंग. आप कोई और भी सीक्वेंस लिख सकते हो, बट कन्वर्जेंस आपको उसकी आनी चाहिए, जब तो आप रिजल्ट कर सकोगे.
सर बट आपने क्या सोच के बर्नौलीज इनइक्वालिटी लगाया कि हम क्या सोचे कि हमको ये लगाना चाहिए मतलब.
अब आप एक क्वेश्चन पूछ सकते हो, सर आपने जितने ये क्वेश्चन कर रहे हो आइडिया कहां से आया. ये जनरल क्वेश्चन है सभी स्टूडेंट है, सर आपका आइडिया कहां से आया. आप जब इंटरमीडिएट में प्रॉब्लम सोल्व कर रहे थे, जब आइडिया आपको कहां से आ रहा था. एक्चुअली देर आर डिफरेंट टाइप ऑफ प्रॉब्लम्स, और उन प्रॉब्लमों को सोल्व करते हैं. तो वैसे इनिशियली ये मैंने सोल्व नहीं करा. सम चीज, कुछ चीज का तो आइडिया मिल जाता है, लेकिन कुछ चीज का क्या आइडिया नहीं मिल पाता. तो दे ट्राई टू प्रैक्टिस, और प्रैक्टिस करने के बाद जिसने भी एक सॉल्यूशन दिया होगा उसने देखा होगा इस तरीके से करें तो वी कैन आल्सो solve the sandwich theorem. जिसने भी सैंडविच थ्योरम दी होगी, सैंडविच वाज द नेम फ्रॉम दिस थ्योरम, जिसने भी ही ट्राइड टू सोल्व मेनी प्रॉब्लम, कि आपको इससे सोल्व करके आप इस तरह सोल्व कर सकते हैं. यू कैन सोल्व इन दिस वे. देयर इज नो, I cannot tell you right way कि why you are using, how you are getting idea to apply Bernoulli's, or where we should apply. Some way, in some question I can give you the idea, but in some question I cannot tell you the direct why you are using. It comes from the practice. आप ये use कर सकते हैं. So sometimes suppose you, in one example of sandwich you use sin n upon n. तो I have one thing कि sin n, range of sin n is -1 to between 1, and if you divide by n, and I also know 1 by 10 to 0, so in this case you are getting idea. Is it clear or not? And here I can give you one idea. This is see 1 plus alpha over n. Here x, idea is I can give you some idea, value of x is less than 1. So how you can write x? Can, if you write any number in this form, okay, so it will be a number which lie between 0 to 1. If you write in this way 1 plus alpha n, now I get idea. This is the binomial expansion, and he tried to apply the binomial from here. Clear? So I think from here you can get the idea. After that you can apply the, you are getting idea from here, because this is a binomial expansion. Now you need to think about the binomial. This is an idea. This is the and little bit idea how you can go. Like sin n over n. If you are using sine, so range of sine we know that -1 to 1, then you can use. Is it clear? This is the example. Is it clear? So that is this. It is actually question itself tell you in which direction you need to go. You need to think. That is, after here you need to think about the binomial expansion 1 upon 1 plus alpha over n. After here, Tushar, Rakshit, sir, we must also write the alpha is very small, smaller than 1. Why? You take any alpha. If you take alpha is equal to 2, the 1 plus 1 upon 1 plus 2 will also be 1 by 3.
But sir, Bernoulli's inequality is only valid if alpha is very less than 1.
Okay, I got it. Oh, okay. You are saying that one. Okay, you are saying Bernoulli. I think this is also true if एक minute just. Actually, binomial theorem is true for this. Alpha lie between 0 to 1. Are you getting? But Bernoulli inequality is true for alpha is greater than 1. Like that. This expression is not binomial. It is derived. I can give you some derivation of this if you want. Bernoulli is this for alpha is greater than 0. कि 1 plus alpha, and if alpha is positive, so it will be this that. You are saying that alpha, because that theorem 1 plus x over n is for 1 plus nx plus nc 2x square like that, and x is lie between mod x is less than 1. That is that thing. I will see it. It should be less than 1 or not. Then I will tell you. I will see it. Okay?
हेलो
Yes.
सर, ये जो अल्फा मच मच लेस देन 1 है, ये सिर्फ इक्वालिटी के लिए होल्ड करता है, पर आपने जो लिखा है वो सही है।
हाँ, वही आई विल चेक, वही मैं कह रहा हूँ कि हाँ दिस इज ग्रेटर देन है ना वो।
यस सर।
ओके ओके, आई गॉट इट। दिस इज एक्चुअली ट्रू फॉर दिस 1 plus n. If you are writing, so this is, I think this is correct. This is correct. I will also cross check, but 99% I am sure that this is correct, because here is equality or here is greater than. Subhanshu Yadav is saying true hai. I am sure 99.9 that this is sure correct. Okay. Any other doubt? Okay. Now I'm doing the ratio test. So before doing ratio test, I want to tell you there is one also ratio test for infinite series. When I will teach you the infinite series, that is different and this is different. Don't relate these two tests. So that's why I'm writing ratio test for sequence. Let xn be a sequence, okay, of real numbers. Obviously, we are working only on near real numbers, such that xn is greater than 0 for all n. All the term of the sequence are positive. This is compulsory. And you need to find this limit n is tend to infinity, xn plus 1 over xn is equal to lambda. If you have a sequence xn of positive term, find the limit of this. If it exists, lambda I am writing, it means it exists. If then it says if lambda is less than 1, then limit of n is tend to infinity, xn will be 0. Second observation, if lambda is greater than 1, then limit n is tend to infinity, xn will be infinity. So with the help of this ratio test, you can find the limit of the sequence xn. Okay. Now, but if lambda is equal to 1, you cannot say anything. You cannot conclude anything from this test. So example 1. Suppose you have xn this is a sequence this n by twice n. Now find limit n is 10 to xn, or check this is convergent or not. So this is limit, check first x n plus 1 over xn. So this will be, I think, n plus 1 over twice n plus 1, and this is n by twice n, or here will be limit n is 10 to infinity. Here this will be limit n is 10 to infinity, and if you solve the, I think this will be n plus 1 above, 2 will be, I think this will be twice n, or limit n is 10 to infinity 1 by 2, and n will be cancelled out. If you take limit, this is 1 by 2. Okay, so here this is lambda, which is less than 1. So by ratio test for sequence, it is less than, you can write limit n is 10 to infinity xn is equal to 0. Clear? Now doing example 2. Before doing example, I want to tell you one thing. Some new students are joining. So I want to tell you, I have uploaded assignment and the all my lecture notes on the website. And I have also shared you the link of the mathematics website. You can go and see assignment. You can download assignment, or if you click on the download, in download tab, all my lectures have been uploaded. You can download also from there on the website of Mathematics 1. Clear? So limit n is 10 to infinity, xn is equal to 0. Now example 2. Suppose you take,
Sir, how did you solve the limit, sir?
ये रही इसकी लिमिट क्या होगी?
सर वो n प्लस 1 अपॉन 2n प्लस 2 की पावर n प्लस 1 वो वाला कैसे आपने n प्लस 1 अपॉन 2 की पावर n लिख दिया, 2n लिख दिया?
ये वाला
हाँ सर,
करना, इसे सोल्व करो इसे. This is simple calculation. Twice n will be cancelled out here too. So n plus 1 over twice n.
अच्छा ओके सर, ओके सर.
Okay.
सर
Yes.
सर हम लोग डायरेक्ट लिमिट एक्सन की वैल्यू फाइंड नहीं कर सकते?
कहाँ से?
n by 2 raised to n
हाँ,
डायरेक्ट
देखो क्या रहा है.
एल हॉस्पिटल लगाएंगे तो भी वही आएगा ना.
This is infinity by infinity.
एल हॉस्पिटल लगाएंगे.
Then you need to apply L'Hopital rule. Okay.
Yes. Yes.
लेकिन बेटा एक बात है, I am not saying that कि this question cannot be solved by other method. One question can be solved by other method, but you can solve this method by sequence, or this is a sequence. और L'Hopital rule किसके लिए होता है? From L'Hopital rule, you cannot say that this is check convergence or divergence. You can also find the limit of by L'Hospital rule. But you can also find the limit of this by this ratio test. So one problem can be solved by many methods. Okay, in intermediate, use yes. Yes. Any doubt? Clear हुआ नहीं बेटा?
Yes, sir.
Any other? Sir, I am not able to find your lecture 3 class recording. I have shared all the video lecture and one more thing, they are more than 150 MB. So you can take from any student. It is very typical to send by my mail because 25 MB is limit. So take from any student. Subhan Jain. So now this is let you have a sequence xn. This is you can take, I'm taking let this is bn over n square and b is greater than 1. Then find again same question. Limit n is tend to infinity xn. Again you can solve by L'Hopital rule, but here I am solving by sequence. So with the help of sequence you can also find the limit of some questions. So again one thing, all terms must be positive. If you want to apply ratio test, this is compulsory to check that all terms must be positive. So here obviously all terms are positive. Clearly xn is greater than 0 for all. You need to write this line, otherwise half marks will be deducted. In above question also, limit n is tend to infinity xn plus 1 over xn. You also need to write this here. Clearly xn is greater than 0 for all n. Limit xn plus 1, so this is this. So it will be limit n is tend to infinity, I think b n plus 1 over n plus 1 whole square and b n over n square. If you solve this quickly, it will be a, I think b, I am writing directly 1 plus 1 upon n square, this will be b, which is greater than 1. The limit is greater than 1, so you can write limit n is tend to infinity xn is equal to infinite. So it is, these are example based on the ratio test. Now there is a question. So okay, Drishti, Santavanu and Shubham, I check. Sir, show upper slide once again, Aditya. I shall check the video lecture of 3. What is the problem? Aditya? More above? Is it clear? Aditya Raj? Okay. Now, I told you if you have a convergent sequence, so this is always bounded. But every bounded sequence is not convergent. That was the converse is not true. So now my main objective is what other condition should be imposed on a bounded condition that it becomes the convergent. What other conditions should be imposed on a bounded sequence that it becomes convergent? It means converge will also be the true. So I am going in that direction. I am trying to prove the converse part, but what condition? With additional one condition. So before telling you that condition, I want to give you some definition. Monotone sequence. It says a sequence xn is called increasing if xn is less than equal to xn plus 1. Another, a sequence xn is called strictly increasing if xn is less than xn plus 1. It means two consecutive terms are not equal. Another, same definition, a sequence xn is called decreasing if xn is greater than xn plus 1 equal to. A sequence xn is called strictly decreasing if same thing xn is greater than xn plus 1. There is no equality between two consecutive numbers. Now what is monotone sequence? Monotone sequences are either increasing or decreasing. So sequences which are either increasing, it may be strict or normal, either increasing or decreasing is called monotone sequence. Now I am going to tell you the main result.
सर मोनोटॉनिक में दोनों आते हैं, स्ट्रिक्टली
नहीं।
और
Or it is not written and.
सर इंक्रीजिंग एंड स्ट्रिक्टली इंक्रीजिंग बोथ आर कमिंग इन मोनोटॉनिक.
अरे यार देखो, okay, here what is this or? What is the meaning of or? Either increasing or decreasing. दोनों कोई सीक्वेंस हो सकती है, इंक्रीजिंग भी और डिक्रीजिंग भी, तो कांस्टेंट हो जाएगी.
सर मैं पूछ रहा हूँ इंक्रीजिंग के अंदर दोनों आएंगे क्या, इंक्रीजिंग और स्ट्रिक्टली इंक्रीजिंग?
Both. It may be either increasing or strict increasing.
ओके सर.
Previously you was asking increasing or decreasing. That's why. Is it clear now?
यस सर.
Okay. So theorem 1 says, suppose xn, you have a sequence xn is bounded increasing sequence. Then the least upper bound, the least upper bound of the set yes Ayush, okay, of the set S. What is the set? Xn, such that n is the element of n, is the limit of Xn. What is the meaning of that? If you have a bounded sequence and you are able to prove that this is increasing, then you can say that that sequence converges and converges to its least upper bound. अगर आप if you add this condition increasing, then converse is also true. Now proof. Since Xn is bounded, if this is bounded by completeness property, then by completeness property, supremum of S exists. Every set which has bounded above supremum exists. Let M is the supremum of this set. Okay, now you have to prove that this sequence Xn converges to M. So you want to prove Xn minus M is less than epsilon for n is greater than some small number. Now let epsilon is greater than 0 be given. Okay, this is given. This is the supremum. So by necessary condition of supremum, what is? There exists a natural number n and not such that m minus epsilon, if you subtract any positive quantity, there must exist at least one Xn naught which is greater than m minus epsilon. This is the necessary condition of supremum. Now, since Xn is increasing, if this is an increasing sequence, so you can write n naught, just wait. This is, you can write one thing, Xn naught will be less than equal to Xn for all n is greater than n naught. This is the increasing. If n is greater than, so Xn will be greater than equal to Xn naught. Okay. Now, I am writing a combined statement. m minus epsilon. From 1, this is less than x n naught. This is also less than equal to xn. Here I am writing for all n is greater than n naught. This is xn. This will be less than m because m is the supremum of the set xn. Or if you add anything, so this will be sticky. So here you can write m minus epsilon is less than xn is less than m plus epsilon. This is, or what is this? You have xn minus m is less than epsilon for all n is greater than n naught. This means xn converges to m or limit n is tend to infinity, xn is equal to m. If anybody has doubt, ask me. So it means, what is this? If you have a bounded sequence, if you are able to prove also that this is increasing, then you can say that sequence must converge. And proof is here. Same result is true for decreasing sequence. What is that? I am writing that proof is same, but in the proof of theorem 2, you use the necessary condition of infimum. I am writing the statement. Suppose xn is a bounded and decreasing sequence. If it is a decreasing, then the greatest lower bound, it means infimum of the set as this is set is same, n is the element of n, is the limit of sequence x. So what is the meaning? If you combine both, if you have a sequence, bounded sequence, and you are able to prove either increasing or decreasing, then you can say this is convergent. Yes. Kale, sir, but why did we take supremum for an increasing sequence function? It will not exist for Kartike. This is an increasing. I am not saying increasing up to infinite. Clear point? This is increasing but not infinite. See the third example of my first lecture. Is it clear, Kartika? Okay. Any other doubt? So this is the final thing, that if you have a sequence which is bounded and also increasing, either increasing or decreasing, so you can say that this is convergent and converges to, if it is increasing, least upper bound. If it is decreasing, then it converges to its greatest lower bound. Today lecture is up to here. If anybody has doubt,